All right, mathletes, here we are solving solutions by equations, equating values of y. So before we've talked about looking and solving some of these graphically, and sometimes graphing is not going to be our best resource because we want a more accurate answers, and oftentimes because answers are not always integers and they don't fall on those lattice points of our graphs, so it's hard to approximate by just looking at our graphs. So a tool that's going to be more useful, quicker, more accurate is solving them algebraically. So today we are solving by equating the values of y. Okay, so in this first example we have y equals x plus 1 and we have y equals 2x minus 1. Well, if both these equations are equal to y, by the transitive property, they must be equal to themselves if we want to find an x and y equal to each other. So transitive property says, well, if y is equal to x plus 1 and y is equal to 2x minus 3, we can say that 2x minus 3 is equal to x plus 1. So notice now we have an equation with one variable. And we know if we have an equation with one variable, we should be able to solve it for one isolated solution. Okay, so to solve this, I'm going to first collect all my x's on one side and all my constants on the other. So I'm going to choose to put my x's on the left and my constants on the right on this one. So I'm going to minus x, and I'm going to get x minus 3 equals 1. And then I'm going to add 3 to both sides to get my constants on the right side. And I get x equals 4. So now I know the x parameter of where these equations are the same. I need to find the y. So I can do this two ways. One, by putting it into equation 1, or putting it into equation 2. Let's go ahead and look at equation 1 and see what solution we get. So we get y is equal to, substitute in my x equals 4 here. So I get 4 plus 1. So I see that y is equal to 5. So that gives me the coordinates where these two graphs intersect at 4, 5. And when I say graphs, these linear equations. Okay. Notice it shouldn't matter which equation you choose to plug your x back into. So I'm going to show you also here, if we plug it into the second equation, we do y equals 2. Again, x was 4, so I plug in 4, minus 3. I get 2 times 4 is 8, minus 3 is equal to 5. My y is equal to 5. The same solution we got here. So just to highlight the fact that it shouldn't really matter. So also with these, we should realize that we could check our answers with our graphing utilities. So for us, we are using Desmos. So if we go to Desmos and I put in over here y equals x plus 1, and over here y equals 2x minus 3, I see the graphs over here, the red. I can see a gradient of 1, up 1 over 1, up 1 over 1, and a y-intercept here at 1. Okay, blue line, I can see I have a y-intercept at negative 3, and it goes up 2 over 1, up 2 over 1. Well, what solution satisfies both these equations? 4, 5. Okay, so let's go ahead and look at another one here. All right, so again, we want to find the point of intersection of these lines or the solution that satisfies both these equations. So by the transitive property, if y equals 2x plus 5 and y equals negative x minus 1, well then 2x plus 5 must be equal to negative x minus 1. Again, I'm going to choose to put my x's on my left side here to try and keep x's positive when I can. So I'm going to add x here, add x here. Okay, and I get 3x plus 5 equals negative 1. And then collect my constants on the right side. So I minus 5 here, minus 5 here, and I get 3x equals negative 6. Divide by 3, divide by 3. I get x is equal to negative 2. Okay, so since I have that solution of where x is on this graph, again, I'm going to plug it in. This time I'm just going to do one of them. Usually when I choose, I like to pick ones that seem easier for me to calculate. I like this first one here because I don't have any other negative numbers, so it'll less likelihood I'm going to make a mistake. So then if I get y equals 2, again plug in my x value here, negative 2 plus 5, okay, I get y equals negative 4 plus 5, y equals negative 1. Well, just for grins, let's go ahead and put it into this one. So I get y equals negative 2 minus 1. Negative negative is a positive, so 2 minus 1 is equal to 1. So notice I have different answers here, but that helps me go back and check and say, hey, wait, negative 4 plus 5 is a positive 1, and now I do recognize I get the same solution. Another self-check here is to do it graphically, right? So graphically, I assume my solution should be negative 2, positive 1. So if I go ahead to my graphing utility and graph 2x plus 5, y-intercept of 2, and a rise of up 2 over 1, and a gradient of up 2 over 1. And I graph my other equation, which is a y-intercept of negative 1, and I have a negative 1 slope. It's going downhill, up 1, backwards 1. Okay. Notice where my solution here exists is negative 2, 1. So a good opportunity in these problems is to always verify and check your solutions. You can do it algebraically by plugging them into both equations or graphically into your graphing utilities. That's it for notes tonight, so please highlight any questions you might have and bring them to class tomorrow.